Alright, example 1 for partial fraction decomposition. Basically what the idea of this is we want to take this fraction which has a factorable denominator and we want to break it into several fractions and add it up to make that fraction. So in other words, what I want to do is I want to take this fraction x plus 11 over, and I'm going to go ahead and factor the bottom, that's going to be x minus 5 times x plus 3. However many factors I get in the denominator here, that establishes how many fractions are going to be in my decomposition. So I've got two factors, so factor 1 and factor 2. I'm going to put the letter A and the letter B on top because I don't know what the numbers are yet, but they're going to be numbers. And A is going to go over x minus 5 and B is going to go over x plus 3. Okay, that's step 1, to create the decomposition structure. So again, the denominator must be in factored form, factored completely. Every factor that's there counts and it gets put over here. Then, I'm going to multiply by this denominator to get rid of all the fractions in the problem. So I'm going to take the entire equation and multiply by x minus 5 times x plus 3. The effect that has in the first fraction, of course, is just we get the top. So x plus 11 is left over on the top. The second fraction, x minus 5 cancels x minus 5. A is left to multiply by x plus 3. And the other fraction, x plus 3 cancels x plus 3, and b is left to multiply by x minus 5. So if I do a little bit of simplification on the right-hand side, this of course is going to be ax plus 3a. And this is going to be plus bx minus 5b. Okay, what I want to do on the right-hand side is I want to arrange things in terms of, we'll call them like terms for lack of a better name. They aren't really like terms, but ax and bx both have x. And 3a and 5b both are just constant structures, assuming a and b are numerical values. All right. So if I come back down here and say x plus 11 equals, take a look at the two red terms. They both have an x on it, right? So altogether, a plus b is being multiplied by x. And I'm going to put a plus sign, then another parentheses, and then we have 3a minus 5b. And what's going to go on here is we're going to create a system of equations to solve this. That's why we're in the system of equations chapter to be doing this. But if we take a look at the coefficients of this structure over here, let me break this apart. Consider x as the red term and 11 as the green term. All right. This is 1x and that's plus 11. A plus b is in front of x, just like 1's in front of x, so a plus b must equal 1. And 11's the constant, just like 3a minus 5b is the constant, so therefore 3a minus 5b must equal positive 11. And just like that, we got ourselves a system of two equations with two variables. We're going to solve that system of equations. I'm going to use elimination. It looks like the easiest way to do this one. I'm going to multiply the top equation times 5. So that gets me 5a plus 5b equals 5. 3a plus 5a is 8a, minus 5b plus 5b cancels. 11 plus 5 is 16. So a must equal 2. And then 2 plus b is equal to 1. So b, of course, would be negative 1. And the request was to find the partial fraction decomposition. What they want us to do is, after we find a and b, go back up here and write out the structure of our answer. So the answer is going to be right here, replacing a and b with their numerical values. So my final step here is just to write the answer. And that's just going to be to take this structure, replacing a with 2 and b with negative 1. So I get 2 over x minus 5 minus 1 over x plus 3.